as I said in like some of the class notes, this will be a very hands-on class. I kind of, from my experience, I found that people really appreciate like getting to interact with the things and not just being told about them. So it's divided more or less 50-50. 50% of the time I'm going to be chatting right up here, and 50% of the time you're going to be working. When you're working, I will be trying, I'll probably like hopefully remember to turn this off, and I'll like walk up and down the aisle and kind of see if you're stuck on anything. I'll be happy to help you. Okay. According to this thing, it's 2 minutes to 9. My phone agrees, so we should be starting shortly. Put all my stuff here so that jungle. Okay, awesome. Let's get this show on the road. So, welcome to the Web Application A to Z tutorial. If that's what you were hoping for, great. If that's not, you're probably in the wrong room. My name is Moshe Zadka. My website is an obscure math joke. I understand that jokes work better when you explain them. So if you come to me during the break, I'm happy to explain the math joke. This is PyCon 2018. And we'll be talking about building modern web applications. I kind of put this prefix modern because I guess they keep changing how to build web applications. So hopefully what I'm going to teach you is how to build things that are kind of current for 2018. We'll try to use modern things as much as possible. So what do I hope for you to take away from this tutorial? I want you to understand the high level, how web applications are put together, what parts there are, how they more or less fit together with each other, when they break, in what way they break, how can you fix them, how can you debug them. I also want you to get the actual hands-on skills, how to actually build each and every part. But 3 hours is a very, very short time, so I'm gonna be like just touching the like really like basic skills. Perfecting those skills take a lifetime. There's a reason why a lot of developers end up specializing as a front-end or a back-end or a database engineer. Here I'm gonna try to give you the skills for all 3 of those, plus like 50% of the skills for a DevOps engineer in 3 hours. So this is definitely just gonna be a taste, and like perfecting each of those literally takes a lifetime. I've been doing kind of more or less DevOps work for the last like 20 years, and I find I'm still learning all the time. So how are web applications built? I guess in the old days, we built web application out of 3 parts. Then people said, like, the middle part is stupid, let's stop that. And that was a good idea. And then we added a new part in the front, and now we still build them with 3 parts. So the front end is made of JavaScript. That's pretty much a constant, because browsers understand one language, and that language is JavaScript. That's kind of not correct, and we won't be kind of using JavaScript, but it's good enough for a first approximation. The backend is where you have almost complete freedom, right? You get to choose the language, the framework, whatever you want, because the users are not exposed to that. That's mostly you. So that's something that's running on your computer. The front end is running on the user's computer. And the storage, often people will, in like especially like modern setups, they'll use something off the shelf, like say Amazon RDS, where you don't even need to install it. We'll be using something slightly less off the shelf because it'll be easier for us here where our internet situation is kind of fraught. So those are like the 3 main parts of our application. Often like there'll be like some parts between the backend and the storage, or between the front end and the backend, depending on which part you like to call the backend. But basically every application will at least have these parts. You have to have something running on the client computer. You have to have some logic running on your server. And you have to have some place to store, unless you really don't care about storing things for more than 10 seconds. Okay, so now we get to make choices. Like anything in programming, every choice you make will lead to like a nice flavor on Hacker News. These are the choices I made. They're reasonably conservative, sometimes not the most mainstream, but like sometimes right adjacent to the mainstream. I think this is like the most mainstream decision I've made because JavaScript is my least strong suit. So there I kind of went with a consensus view. React is a JavaScript framework originally created at Facebook. So I kind of learned it when I was working on Facebook. It's pretty decent. It's pretty easy to use. It's not the most performant, but it is the easiest one to get a decent performance on, which I find more useful than being theoretically the most performant. Then for the backend, the first choice is easy. This is PyCon. I'm going to teach you how to write web applications in Python. That's also pretty mainstream. I guess like, there's Ruby on Rails and there's Node and like some people do stuff in Go, but Python is definitely a very big leader there. I don't know if I'd put it number one, definitely at least number two, and a safe choice for PyCon. We'll be using WSGI. That is definitely, like if I had to kind of put like a mainstreaminess, that is definitely the most mainstream on here. Like every single Python web framework that is not super exotic uses WSGI. That's the web standard gateway interface. It's kind of a joke on a really old standard called the CGI, the Common Gateway Interface, which is so old that probably none of you know it, which is good because it was really bad. But WSGI is really nice because it lets us use almost every Python web server with almost every Python web framework. So it's a good kind of way to kind of make sure that your choices for server and framework are disjoint, which is really important when you're making choices because some people have strong opinions and sometimes you're wrong. We'll be using Pyramid. I guess Pyramid is like the least mainstream choice I'm going to make here. It's definitely one of the big three, right? But it's like the third one. So there's Django, which is definitely like the biggest one. There's Flask, which is definitely like the best one at being kind of the contender. And there's Pyramid, the one that everyone forgets about until they remember that it runs a lot of stuff. If you have enjoyed the new PyPI, the new PyPI is all Pyramid. So at the very least, I'm giving you the skills here to go and help on the new PyPI. If anyone wants, I'm sure Donald Stuffed and Ernest will love seeing your patches. So hopefully I'll give you the skills for that. So Pyramid is nice. I like it because it's not quite as constraining as Django, but it does have a little bit more structure, so it kind of scales better than Flask. Different people like different things. I guess I get to make the tutorial, I get to make the choices. Storage. Wow, databases are even more complicated than web frameworks. Certainly strong opinions there. Here, SQLite is definitely not something you'll almost ever use in production, probably for good reasons. However, it's definitely the easiest one to start with when you're coding up a prototype. It definitely can scale you up to like the point where you're worried that you're scaling up, and hopefully by then you have actual, like people using the application. So it can scale up more than a lot of people think. Very easy to deploy, and much more importantly, we'll be using SQL Alchemy. SQL Alchemy is a way to abstract the database server. So because of that, you'll find we almost have no SQLite-specific code. We basically just configure some environment variables, spoiler, to say that we're using SQLite, and like our code will actually be using SQL Alchemy. That is definitely how you should be writing web application code if you're using Python, because you will change your web server, so your database server at some point. Like, at least you want to assume that you might have to. Right? Like, if you chose MySQL, that might be wrong, and if you chose Postgres, that might be wrong. Just assume that you're going to make a wrong choice and kind of live with it. So this is, we're doing pretty well on time. Pretty good. Okay, now there's like the bit that like nobody remembers. Web applications don't, like I guess like nowadays some people literally use serverless, but unless you're using serverless, they need to run in something. So I already alluded to like the WSGI container, right? So we use WSGI as a way for the web framework to talk to the server, but we need the server for it to talk to. We're going to use Twisted. I guess the other big contenders in that space is Gunicorn and UWSGI. Once again, I can say that Twisted is definitely like the third one in that list. And once again, I can say that PyPI uses that, so it can't be too bad. I like it because it's very flexible. We'll kind of see how some of its flexibility come into view as we don't need to put Nginx in front of our web application, which is a lot of fun because let me tell you, the Nginx configuration language is not fun to figure out. And Python is a nice language. Hopefully you all agree. So Twisted is configured with Python. You don't need to work with INI file or the weird semi-specified Nginx configuration language or the Apache configuration language, which is better specified but a worse language. We'll pretty much using Linux to run it. If you're not using Linux, that's fine, because the modern way to use Linux is to make sure that you have a Linux virtual machine, then you set the Linux virtual machine to run containers, and we call that Docker. So we'll be using Docker to containerize our application. Docker is really nice because you can build a build artifact, run it on your laptop, make sure that it works nice, and then ship it off to wherever you're running it in the cloud. And it kind of divorces you from having to decide early on how you want to run it. Like if you use Docker, then you can run it on Heroku, you can use GCP, that's a Google Cloud platform. You can use AWS with either EKS or ECS. And you can, of course, use your own computers and just run Docker server on them. So it kind of like gives you the freedom to make choices later. You know that a lot of like things they do is like, here's how you make sure that you're free to make choices later. That is good because choices you make early on are often bad, right? Like if you choose initially to run on Heroku, that is great until you realize that you're bleeding money and you want to switch to AWS. If you use Docker, switching from Heroku to AWS is pretty painless. So painless in switching, that's kind of like what I like to optimize for. And then the part is like a lot of people forget. That is a very unfortunate thing to forget because you will have bugs. You don't probably want customers to see that bugs. The end-to-end testing arena is like very, very complicated. Selenium is definitely like a leader in that. That's probably a safe choice. There's a couple of commercial platforms that I definitely didn't want to show here, like we use at work, some like cutting-edge, weird commercial platform for automated tests. That's great, but if you are just building out, you probably want to have something that just works. So Selenium is a way to drive browsers so that you can kind of simulate a user, but needs a browser to drive. So you think, well, great, Firefox is a great browser. Let's have Selenium drive browser. No, it can't drive browsers. That's a lie. I just told you a lie. What it knows is how to drive something standard, and then that something standard can be built to drive Firefox. So we use Gecko Driver. So Gecko Driver is something that wraps around Firefox and uses like this kind of common driver platform that I forgot the name of, but there's a standard for that, to have Selenium drive Firefox. So with these three together, we can basically have a virtual Firefox that can simulate user behavior. So we can say the user clicked on this button. What is the user seeing? Grab me the HTML, grab me the DOM. Let's kind of dig around and see that like the word foo is actually there. So you can actually simulate like a user session. I guess like I kind of completely skipped over unit testing because I don't care about unit testing in this tutorial. You should care about unit testing in general in your life. But for this tutorial, it doesn't matter because I'm teaching you how to write web applications. So the thing I minimized in this tutorial is business logic. You'll notice that almost the applications have almost zero business logic. That's because, hopefully you could just, read the Python tutorial and learn how to write, logic in Python. You usually want to unit test your business logic. Unit testing your routing stuff is usually not important. But what you want to do is end-to-end testing on that. So, while in real life, unit testing will end up uncovering a lot of bugs, the kind of bugs that are uncovered by end-to-end testing are their own kind of bugs. This is when you, the JavaScript part is talking to the Python part, but like it sends it the wrong JSON, right? You're never going to figure that out from a unit test. You need an end-to-end test for that. So when people forget it, what they end up doing is basically having users do their end-to-end testing, if you like to do your own end-to-end testing and not give it a subword. If you like to have users do the end-to-end testing, that's fine, of course. But if you enjoy people interacting with your application to interact with a working application, then you probably only use that. So Selenium is a platform, right? It basically understands how to drive more or less web browsers, but you still need something to actually tell Selenium the actual test logic. Like what to do, like first log in, then click on this button, then write a post, then check that the post is there, so on. Python is a good language for that. People have been using Python for end-to-end testing since before people were using Python for applications. Like a lot of companies started using Python for their testing and only then started using it for the production applications, certainly in the before times where a lot of the end-to-end testing was to drive C++ applications. So Python is definitely a safe choice here. Installing Selenium, Gecko Driver, and Firefox correctly is to a first approximation impossible. When I say it's for first approximation impossible, I mean I have a lot of experience with a lot of these technologies. It took me like 10 hours to get all these things kind of working together more or less. I assume for anyone who doesn't have a lot of experience, that translates to like 2 or 3 weeks of getting that. Like no manager will ever actually let you have those 2 or 3 weeks. There's just cheap bugs, whatever. So Docker comes to the rescue once again, right? There's a reason Docker is again here. You don't have to use Docker for your end-to-end testing, even if you're using Docker to run your applications. But if you want to make sure that your stuff is actually installed correctly, especially if you want to upgrade your Firefox to make sure that you can simulate bugs on new Firefoxes, or if you want to downgrade your Firefox to make sure you can simulate bugs on all the Firefoxes, this works out really well. So we'll build a Docker container that is just designed for running the end-to-end tests. Whew. Okay, so let's start by talking about how you build applications with Pyramid. So the application we'll build will be, sometimes people call it single-page applications. They use the acronym SPA, which is really annoying because I like SPAs and they should not be describing application frameworks. But that means that the Pyramid part, the part you write in Python, will never show an HTML. It will just be responsible for logic, and usually what this means in modern terms, it will be sending JSONs back and forth, right? And you assume that there's something on the other end, some like, in this case, a React client, but you can use JavaScript, or you can use even like a native app, right? Some people do that, to actually communicate with the web server. No human being will actually go and look at the Python, at the Pyramid output or communicate with it. I guess if you're looking for like a reason why I put the modern in the beginning of like what I described, like this is a modern web application, right? Human beings do not go to the application directly. They use JavaScript as an intermediate. Right, so the imports are fairly standard. I just put them here so that like we remember that like you need to import stuff and that you know where things go. This is the most basic hello world. This is not even JSON, right? This is just a plain string. It does not have HTML. It does not have JSON. But it's okay. You can, like, if you want to just prototype something quickly with Pyramid. What you'll notice if you use to a lot of other web frameworks is there is nothing around this function. This is a Python function. You can call this Python function. It will return a value. That value will not be a string hello world. It will be a response, but you can inspect the value, right? I realize that like saying that this is a Python function that you can call doesn't sound surprising unless you've seen other web frameworks where there is no Python function you can call which will return a response, right? In Flask, you wrap your application, you wrap your function, so by the time it's wrapped, it's no longer like a Python function that you can actually use in any sane way. And what it returns is definitely, and in Django you write this whole class and it assumes you have a context and like trying to run that. So the nice thing is that like I told you I'm not going to cover unit testing, which is true, I'm not going to cover unit testing, but you can unit test that, right? This would be stupid to unit test, this is obviously correct, but if this was actually had logic which would look in the request and decide like whether to say hello world or goodbye world, you could test that logic. You could just call the function. You don't need to run a web server, you don't need to do anything. So this is kind of nice. I like it. The business logic is just Python functions. I like Python functions. This is no longer a Python function, right? This is like the Pyramid part, right? So you need to actually tell Pyramid to call that Python function when something happens. Pyramid uses a weird indirection of routes. It does help when you have bigger apps. It's kind of slightly annoying when you have a trivial app like Hello World, because we say, okay, so the logical route hello corresponds to slash. So when people go to slash, go to the logical route hello. And then you say, when people go to the route name hello, please show them the function hello world. The advantage is that you have a separation between the logical layer of your application, which things you are showing people, and which URLs you're showing to people. This is often important when you want to refactor your URLs. Like some reasons to refactor your URLs is maybe you're using something like Logly and you want to be able to filter. Say, oh, you know what? Like everything that goes to that section is like one logical thing. I want to easily filter it in my view logs and stuff like that. So this is definitely not important when you're writing your application, which is great. So that means you can choose however your URLs, however you want here, and later when you need to refactor it, when you know more about your application, you know more about your use case, you can change the URLs around and it will all work. So there are benefits to that. And then you'll notice that I do make WSGI app, right? So what this all gave me is I took my function, my business logic, and I kind of mushed it around into a WSGI app. So WSGI applications are just a Python object. The WSGI standard is kind of complicated. If you like reading standards, I guess it's a weird hobby, but I have it. If you're like me and you like reading standards, you can read the WSGI standard and see like exactly how it calls it. But again, for most frameworks, you don't have to care about it. The framework will make sure to build you a good WSGI object. This is how Pyramid builds your WSGI object. So you just build the WSGI object, and now you just need to serve it. So remember, Pyramid is a web framework. It is not a web server. It knows how to use WSGI to talk to a web server. This is its entire responsibility. This means talking WSGI. This means creating an object that understands the WSGI protocol. There's different ways to run WSGI applications. One of my favorite bits about Twisted is that the WSGI way to run, the way to run WSGI applications with Twisted is just running the command line. If you don't need anything special, we will need special stuff early on. You need to write 0 configuration files. You need to like do 0 environment variables. You just write a command line. It does assume that you can import the module hello, and that app is an object in it. If you notice, we have an app, right? So that creates a global variable called app, which is a WSGI object. So this tells Python, please run Twisted, give it the parameter web, give the parameter the argument minus WSGI hello app, and this will actually work. So I think you even have the files needed for that in the repository I gave you. It's not going to be important, so if it's not there, don't worry too much about it. But you can actually do that, and this will actually give you a working web server where when you go to slash, you get hello world. This is super important to have like something that easy to start with, because then you can actually go to that server and check that you see hello world, and if you don't, you know that you've done something wrong, and if you do, you know that at least you have like everything kind of wired up, that you actually have a browser to manually test your application with. Okay. So as I mentioned, we'll kind of work on storage later. So for now, we're not going to have storage. So we'll just have, the application we'll be writing is a shared unauthenticated blog, because this is literally the easiest application I could think of that does something halfway interested. So this means people post stuff, and it shows in a reverse chronological stream, and it does not ask for authentication. It's like Twitter, if Twitter was even worse than it is, but without the 140 character limit, so, you know, trade-offs. But this is really like the simplest application you can think of. I don't want to start messing around with authentication because, wow, that's like a whole can of worms that like I could probably spend a whole tutorial just about that. To begin with, we just hard code our posts in memory. Later on, we'll use like some real storage platform. Not maybe very deep thoughts, but this is the internet, so I don't know if you're expecting to go to a shared blog and see deep thoughts. Okay, this is our logic, right? It should look familiar. because this is basically just the same thing as a hello world, except it does something slightly more interesting. You almost want to encode JSON in UTF-8. If you don't do that, by the way, it will say that, oh, this is a Unicode string. I can show a Unicode string to the user. That is correct. Like HTTP is a wire protocol. You can only send bytes over the wire. You need to make your strings be bytes. Literally, I think a year ago, they finally said that UTF-8 is the official encoding of JSON, after everyone was doing it in practice pretty much. So we don't even need, like, theoretically, like, you really should have like an encoding argument here, but nobody needs that. And nowadays it's not even important. So we just take the post argument, which is, if you remember, a list of strings. We encode it into JSON, and we ship it. So this is the same thing as the hello world, slightly more complicated, but nothing to it. Again, notice that there are no like, decorations or anything around it. It's just a function, takes an argument, return an argument. Okay, and we have in add. I kind of want to talk a little bit about add here. And the reason I want to talk about add is we're using Twisted to run our thing. This is really nice. Among other things, it's nice for this specific prototype because Twisted will be multi-threaded but not multi-processed, which means having a post thing that's in memory is fine, as long as we remember to keep all our code thread safe. This is not something you ever want to do in production. This is something that's really, really nice to do for like, you know, testing out ideas. So, like I said, we'll move to like a more production-grade storage solution later, but this basically saves it in memory. .append and JSON dumps are thread safe, so that's fine. This will work. And like when people append, you'll actually see that. So this is actually a fully working application. I think it should, like, I think I called it app.node.db, so it'll be slightly annoying to run it because the real application took over the app.db in the repository. But you can actually run it, and you can, like, you know, put mindless posts in, and it will show you the same mindless posts in the JSON. Right, like I said, this is not something a human being will, you know, normally interact with because this is just, you know, it assumes that you send a JSON with the argument content and that you like getting JSON in response. Probably not something you want to show on a web browser, but if you just want to play around with the application, see how it works, that works great. By the way, how am I going? Who thinks I'm going too slow? You're doing good. Who thinks I'm going too fast? Wow. Apparently I've reached Zen. Okay, so slightly more complicated routing. You notice that like, I still have the routing logic far surpass the business logic. That is intentional. The business logic was very simple because writing a shared unauthenticated blog is very simple because what I really want to teach you is this part. Like, you know, like again, like, you know, writing business logic, you can just, you know, learn how to write Python code. This is the interesting part, right? So I want to say that post is available on /path with get, and that add post is available on the same URL, but with the request method post. Right, this is again a very typical, some will even say RESTful, although I can talk a lot about REST. It's technically RESTful, which is the best I can say for that. But yeah, anyway, this routing will work. It will make a WSGI app that is completely functional and will actually be all the backend you need for a shared blog if you don't care that every time you restart the web server, you lose all your posts. Which, you know, for some things is fine. For some things, that's fine, I guess. But the important thing is this is fully functional, right? This, I've literally not left out one line of code that will be needed for making a functional backend application. So if you really do understand everything I've shown thus far, you should be able to, like, you know, use that knowledge to actually make your own web applications for JSON. Let's see actually how fast I'm going. Wow. This is exactly according to plan. All my hands-on stuff is like, the column is like how many minutes have passed since 9, and like the other thing is like how many minutes should pass by the time at the end of the exercise. So get the application to run as is. If you clone my repository, it should be under hello.app. And then if you do manage to get it to run, so I hopefully got you, like you can literally test this with a browser, at least to kind of see the post. You'll see JSON in your browser, which is maybe not the most fun, but I do it every day for work, so it's not the worst thing. There's even like nice plugins for Chrome if you do it a lot for work, which will like actually make you, see the JSON nicely on your browser. And then once you got it to run, add an author field. So it will be unauthenticated, but at least non-anonymous. If you're done with that, try to add a date field. And if you're done with that, try to see what it would take to update a post. I intentionally gave way more work than you're likely to manage to do in 15 minutes so that you won't get bored. Hopefully try to get the application to run as is a realistic goal. I hope some of you will actually get to add the author field. And I would be surprised if anyone gets all the way out here. I don't think I could probably do it in 15 minutes, so if you do it, you should probably be teaching the class instead of me. Yeah, just go ahead and try, and if there's any problems, just raise your hand. I'm gonna be turning off my sound, so when I help you, I can just help you in person. Okay, just 1 second. Just to kind of try to iterate some points of confusion that I saw common a little bit, you should definitely be on an activated virtual environment, and the application is available in your code under blog no app underscore no author. So you should find that there. So that's the application you should try to edit this is. And just, you can go ahead and edit in the no author file directly. You can't, you can commit, but that's okay. You can't push to a repository accidentally, so feel free to add it in place and see if it works. Okay. Just 1 second.
So you said the app that it's in the blog directory?
Blog, app, no author.
App no author, okay, thanks.
Yeah, see, that's not how you want to, remember like I showed explanation? Can you open the PDF in there? The handout PDF? No. Okay, good, good. Okay, so we have the backend all set up, right? You can see the post, you can list the post, but unless you have the nifty JSON extension that I saw some of you running, this kind of looks ugly, right? Like you open it and like open bracket, blah, 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 close bracket. Doesn't look anything like the web applications you're probably used to if you, go to Facebook or Twitter or anything like that. So let's start of doing that. So we are going to use React, as I said earlier. The first thing you need to do for React is to load the right JavaScript things. Nowadays, you'll find lots of people not recommending to put the loading of JavaScript as a header, but it does simplify code a lot. So unless you're trying to really squeeze that last bit of how fast your web application startup is, it's fine for now. So we're using React, and we're using an extension called React DOM. Those come from Facebook. And React uses something called JSX. I think it stands for JavaScript XML, which is this. So like I told you, I kind of lied when I said everybody writes in JavaScript. The truth is that nobody, to a first approximation in the entire world, actually runs in JavaScript. If your definition of JavaScript is stuff that browsers can run. Nobody does that, right? What everybody does in real life is they write in a language that's very similar to JavaScript, and then they use something called Babel to transform it into the language that browsers understand. Why does it do that? Because browsers move very slow. By browsers, I mean people, of course. People hate updating software. You can push the update in their face as much as they can. Not yet, not today, sorry, not today. So browsers move slow. This means that all the nifty things in JavaScript that modern JavaScript has that actually make JavaScript into a usable language are not there in browsers to a first approximation. So what people usually do is they write the language in the latest version of JavaScript, or sometimes the version of JavaScript is all kind of extension, like there's TypeScript for Microsoft, which is very popular. And then they compile it to JavaScript. Because the languages are very similar, they don't call it compile, they call it transliteration. And almost all of those are managed by Babel, so we're using Babel. And like everybody else in the world, we're of course not using JavaScript. What we are using is JSX. That's how you write React applications that are reasonably resistant to XSS. Who knows what XSS is? Wow. So XSS stands for cross-site scripting. So remember how, literally 5 minutes ago, you were all writing things that allow people to fill in boxes on their UI and push stuff over to your server, and then your server happily posted that. So that was fine because we use JSON, right? So even if they put things that look like JSON, like open brace and close brace and other things, JSON would protect it. So this would be safe. So the path from your server to the browser would be safe. But what about the last path, right, where the JavaScript interprets this, right? So if they put stuff that looks like HTML, are you actually going to inject bits of HTML into your HTML? That's really, really bad. People can do really bad things, starting from just messing with people. So, usually when a site allows that, the first people who will find will be the pranksters. All kinds of pranks. But basically, you can completely own people with that. I can even steal your cookies. Which this doesn't matter, this doesn't have cookies, we are unauthenticated, but usually you probably care a little bit about your cookies through Facebook or Twitter or your banking website or whatever. So JSX is a way to write web application in a way that naturally makes you not have XSS rules, have XSS flaws. If you try really hard, you'll manage to do XSS, but the default is to not have it. Whereas if you usually use JavaScript, the way JavaScript is kind of the way the natural affordances are, you'll end up setting an inner HTML to something you really hope doesn't have HTML, but does have HTML, and then the end of the world. So not good. So that's why we're using JSX. That's why Facebook uses JSX, by the way, because of exactly that reason. People type stuff into Facebook. Some people like to prank other people. Sometimes people like to do things that are worse than pranking other people. Facebook obviously doesn't want this to happen. In the body, this is pretty much all you need. Sometimes people will have like a little bit of like static decorations around it. Sometimes people will have some static decorations around this to kind of usually have some loading screen that then you remove with JavaScript. But this is the only thing you actually need. This is just, hey, React, just fill up this area. Well, how does React know how to fill up this area? That you actually have to tell React that. But you need to have that area in your HTML for React to fill in. So as I said, you use text bubble, right? This is the wrong way to use bubble, by the way. On the other hand, it's very, very useful to use bubble in this way when you're still developing your application. It just means that loading it will be super slow, because that means that Babel will have to translate this into proper JavaScript at browser load time. This is extremely unpleasant if real users actually use your application. This is really nice if you're the main user of your application while you're developing and you want to try out stuff. In real life, you probably want to use Webpack and stuff like that. Definitely no way I'm going to get that in 3 hours. So that will be like part of the extended reading I'll give you at the end. But this is how you write this stuff. This is like a very, very simple thing. This is like not dynamic. There's no reason for me to do that in JavaScript. I could just have an h1 hello in the HTML. But this shows you the main building blocks of React, right? So you'll usually define objects. This is just a JavaScript object. And you'll notice that I can literally just switch in the middle from writing in JavaScript to writing in HTML. And this is going to be safe. Right, so this JavaScript has understood, it understands that, it should, treat this as HTML. And then I just tell it the item you want to render into is the item I've marked with content. So remember earlier I said you need to tell React where to fill in. This is where you tell React this is the one you should fill in. Theoretically, you could render 2 different React applications. Don't ever do that. You'll confuse yourself. You confuse React. And this will be bad times for everybody. This is how you should write code. On the other hand, you might want to not have a constant element. Usually you'll want to have an element that's like an instance of a class that does something interesting. Otherwise, you'll be just writing HTML. So static and dynamic is kind of like weird words. HTML and JavaScript are static. The reason they're static is because you write the files and then you serve the files. You do not process these things, right? In this case, all the other URLs are dynamic, right? This means that when someone goes to /posts, you actually ran some calculation. Calculation was trivial. It was just doing a dump of posts. But it is a calculation, right? This is computation that goes up in your server, and it's going to be different from time to time. If you modify posts, then the computation gets different inputs and therefore has different outputs. So the other URLs are dynamic. You go to them and they serve different stuff. The HTML and JavaScript are static, right? Even though they are dynamic on the front-end side, this does not impact your server. So in our case, the /posts URL. The URLs that are not backed by files, but are backed by logic. So what usually people do is they'll put a proxy in front of the WSGI. The most popular choice nowadays is Nginx. That means now you have to learn 2 things. And you have to learn the Nginx configuration language, which is very unforgiving. The documentation, if you don't read Russian, is kind of bad. It's translated from Russian. Really, like by default, I think it used to go to the Russian website and you had to click to the English one. And it's sometimes unreadable and quite annoying. And it will be really performant, right? But presumably when you're building stuff, what you care is not about performance, it's about how easy it is to get off the ground. So instead of putting proxy in front of WSGI, which I definitely didn't want to teach you, because remember how hard the setup instructions were for some of you? Imagine if I added install Nginx to the setup instructions. This doesn't install in the virtual env. No, now we have to figure out how the operating system packages work or compile it from source. Yes. So exactly as unpleasant this is for setup instructions for a tutorial, it's also, okay, I should probably move away. It's also unpleasant to do that in real life, right? different unpleasantness. Now you have to figure out how versioning works and how upgrade works, but it's no more pleasant. So what we'll do instead is we'll write a custom Twisted plugin. We are already using Twisted to serve our WSGI. Twisted web server is fully functional. It can serve files. So we could actually configure Twisted to run two servers, a reverse proxy in front of the WSGI and then put other stuff. But there's no need. We can literally run the WSGI and the static stuff in the same place. We just have to learn a little bit of Twisted. If you're afraid of Twisted, this is the last day you can say that you're afraid of Twisted. Except for the import list. The import list is admittedly scary because we're going to use a lot of bits of Twisted. But we actually don't have to run any async code. All the code we'll have to write will just be the initial configuration code. Twisted already has all the async it needs. But we do have to import a lot of things. The import list is not as interesting in its contents as in its length. We're going to use quite a bit of Twisted, but it's fine. Twisted is fun. And what we'll be writing is the delegating resource. So we do have to play a little bit tricks with Twisted. We have to understand a little bit how Twisted thinks about resource trees. That's fine. So a delegating resource is something that will delegate all of its dynamic children to this guy, who will pretend like it didn't get child, and we just return the WSGI resource. This resource will only work correctly if you put it on the root. That's fine, because that's where we'll put it. The important thing is that this means that like every time it doesn't know about something, it will just call your WSGI resource. That's a little bit of wrapper around your WSGI resource. Why do we need a little wrapper? Because we need to have some place to put the files in. Before we have a place to put the files in, we have to configure our own pool. This is actually really, really useful, even though it doesn't look really useful, because Twisted by default runs its own thread pool for WSGI. At some point, you'll probably want to configure how many threads it's running. Twisted has no idea what kind of Docker container you decide to buy from AWS or Heroku or GCP. It does not know how many cores it has. It does not know how fast it is. It knows literally nothing about your application. So you'll probably want to, in real life, this code will actually be a lot more interesting because it will actually like check the environment and see how many, what is the minimum number of threads and what is the maximum number of threads. And maybe you're in the middle of performance tests, so you probably want to like do some A/B tests. This code in real life will be like really complicated, but it's good because the alternative to having this code be really complicated is to have your Gunicorn before it starts up, write its own INI file and like put all the complications there. This is no less complicated. This is just like more places for things to go wrong. But for now, we'll just use a default thread pool. Oh, did I skip something? Yes, I did skip something. Okay. So now we come to like where you use the delegating resource. So we build the WSGI resource. We give it the pool. So if you have two different WSGI resources in your application, which is usually not a great idea, but if you do, you can actually give them different pools. We'll create a delegating resource, and then we'll add the static files we need. Right? So if you remember, we wanted to put the index.html, right? Because this is a single-page application. There's only one HTML file. The HTML file is index.html. But we have a bunch of JavaScript files. They are all under static. And by the way, this technique scales well to also deal with images. Like if, you know, like I am really not the world's best UI designer. Biggest understatement ever. So I didn't want to like, you know, make any custom icons. In real life, you'll either make or, you know, hire someone better to make icons for you. You'll probably want the icons and all the images and all that stuff also to be under static. So this is in general like something you'll need, right? Even if you are doing like different style of application, but definitely for single page application, this is a very typical structure. So this is actually interesting. I have 0 options. Why do I have 0 options? Because I know what I'm running. I'm going to be running like the blog application that this is a custom Twisted plugin. This is not a generic Twisted plugin. This is not a Twisted plugin you're going to put on PyPI. This Twisted plugin is going to be part of your application. The person who's editing that plugin is also going to be editing the application. This is important. Remember that I literally put static and index HTML in the files because I know the structure of my application. This really doesn't try to be a generic plugin, so I have 0 options. In real life, you'll probably find at some point you do want some options, maybe to distinguish your dev environment from your prod environment to do something slightly different, but definitely as a first approximation, 0 options. Python is a great configuration language. Write your configuration in Python, unless you really need to differentiate between different environments that your app will be in, right? Like there's no need to put your plugin on PyPI and then write another configuration layer. You can just write the plugin that you need. And then I just, get the pool, I get the root, I make the server side, I tell it to run on port 8080. Again, notice, no options. I know that my application is gonna run on 8080, right? If I was doing another configuration, if I need to be behind TLS, I can hard code all these things in. Hard coding is just like not a good word because it's not hard coding if it goes into software. The reason the word software has the word soft in the beginning, this is not just like, semantics. Software is because it's easy to change, it's malleable, it's just text files. If you need to change it, just change the text file. You don't need another text file to have the configuration parameters in it to put the config to change that. This is also a great text file. You just have that. So this is actually like what I recommend doing, right? Like, put all the configuration logic in Python unless and until you know that you need to differentiate between environments, then use the options. How are we doing on time? I think we should be good. So again, to run it, you should just be able to use blog. I think I just put the under in it so that by default it will run the right thing. If not, then we'll have to fix it. And now you should already have the custom plugin. If some of you have seen the twisted directory in there, that's where the custom plugin runs. Again, the first challenge you have is get it to run. From the previous challenge, you remember that getting things to run is actually like a big part of the challenge. This is actually like pretty typical. Like getting the first thing to work is like a lot of what I'm trying to teach here. Like making sure that you understand what kind of errors you get when you do it wrong and how to fix them is exactly what I'm trying to teach. So get it to run. If you're finished, add a fav icon. That should go in fav icon. The way you know that it worked is when you go to that website, you'll see like a little bit of thing in your browser. Where Twitter shows a little bird in the browser, not inside the website, but inside what they call the Chrome of the website. You see a little bird when you go to Twitter, like right by the URL. That you know that you've correctly configured your fav icon if you actually did that. So try to add the fav icon. If you are finished with that, you can try and add a few posts and requests and see how it works. And if you are finished with that, you can actually add a parameter to control the port. Imagine that we actually do need to change the port between environments, add this as a parameter, see how it works. Again, I don't think I could probably do all of that in 15 minutes. I hope you guys at least get to run. And if you're doing any of the others, that's great. As a fav icon, choose any image that you can, or make your own if you really enjoy that. I don't. Okay, so you have 15 minutes. So that's until, okay, we're like 10 minutes behind, which should be okay. But so we'll finish it at 7:15. We are 10 minutes behind. So, oh, yeah. So the plugin I wrote is too well hard-coded, and it's currently hard-coded to use the DB version. So your first, I guess, exercise is to make sure that you're pointing to the app no DB and not to the app. So the plugin code is blog/twisted. So that's part of the exercise to kind of figure out, like, and again, this is like very typical for real problems. So I'm actually glad you saw that. Good luck to get it to work. So for those of you who have Windows, you'll probably need to install the package PyPI Win32. This is literally the name, pip install PyPI Win32, because Twisted needs it, but doesn't depend on it properly. I'm sure there's like a magic string to give Twisted to actually depend on it properly, but I guess I didn't find it because I never debugged the instructions on Windows, so sorry about that. Pip install PyPI Win32. So understanding how to get things to work is probably the most important skill that I want to teach here. This is important. Let's spend a little bit more time on that, and then we'll maybe rush through some of the other explanations. And if we get to a little bit less, that's fine. You should have all the information in the handout. I want to make sure that what I am teaching you, I'm actually teaching you properly. I misread the time. Now you should go out and get food. Then you can come back in here and do more exercise. This is the time where the food is out. If you're in my class, the web applications, we're starting again. Okay, so welcome back. I've read somewhere that the most important duty of a tutorial speaker is to make sure the class is out for food before all the good stuff is gone. I don't know if I'd put like blueberries and blueberry muffins and cinnamon muffins and the good stuff, but hopefully you enjoyed what we had, and it wasn't gone by the time you reached it. So if it is, I did the only important job I had to do in this conference. So Python is a great language. Hopefully you're in this conference and you all agree that Python is awesome. Unfortunately, on the web, we usually have to use JavaScript. So this is the less fun part of the tutorial where I teach you how to use JavaScript. I kind of pretend to know JavaScript sometimes. Hopefully I'll manage to pretend well enough for today's needs. So like I said, we were using React. Earlier when I showed you a quick demo of React, we just used a constant, which just like had an h1. That was nice for demo, but here we want something to actually have logic. So we write classes. One of the benefits you get with React is that you get proper classes and not whatever prototype weird stuff that JavaScript sometimes has. So we have a class. It looks decent, except like there's curly braces everywhere because it's not Python. And the constructor is named constructor, not under init. But other than that, it should kind of feel familiar. We call super. This also should be familiar. You usually call super in a constructor to make sure that the parent class is properly initialized. And then we initialize a member variable called state. JavaScript uses this and not self because they're wrong. And here we just have a dictionary mapping posts to an empty list. State is a variable that is important to React. Like this is how it should be called, state. And this basically represents the state of the data as you see it currently. Some people who don't like that use React with something called Redux, which I definitely don't have time to cover. So we'll do like plain React and we use state. Now, JavaScript is really, really weird, as I've said several times. Like a large part of this part of the tutorial is me complaining about JavaScript, but also in a way that hopefully like explains why I'm complaining. So you'll see that I'm rebinding the two methods. The reason is if you kind of are used to Python, you're used to like, you do self.method and that's an object. And you can call that object and remember the self. That's called a binding. That's because Python does this automatically because Python is right. In JavaScript, if you need to pass the method around, you need to explicitly bind it, or it does something called in JavaScript land this capture, which means it takes the wrong this. This is really annoying to debug. It takes like hours to figure out why it's not finding like the state that you've explicitly stated. Almost always, this is a bug. This is how you fix it. You explicitly bind the methods. This means that now the handle submit actually has a this in it. This is the same thing that Python automatically does. In JavaScript, you have to do it manually. This is great. It's definitely a good reason why this language is the most popular language in the world. So in the constructor, you notice that we didn't do anything interesting, right? We just set variables and some methods. We didn't do anything that affects the page. This is because the constructor is run before the page is ready. Like the JavaScript DOM model has this whole sense of like page being ready. And if you don't use React, responding to that event is really, really annoying to figure out when you need to respond. In React, it's really straightforward. You just implement the method component did mount. Component did mount, is the method it calls when it says, okay, the page is ready for you, go do your thing. And what we do is we just fetch the slash posts. If you remember earlier when you went to slash posts in your browser, we saw a JSON list. Or if you like change the data structure after I asked you to add the answer, so suddenly it's a JSON list of other stuff. But it's just JSON. So I'm telling it, okay, go. So this means that basically the browser will go there, but instead of displaying it to the user, it will return it to the JavaScript, and then it will tell the JavaScript do something with it. So JavaScript is event-based. This is great for people like me who are used to Twisted or async IO and are writing all the code in event-based. If you're used to writing synchronous Python, as say the pyramid code is, this will be a surprise for you. Everything is in callbacks. You don't ever do anything in JavaScript. You say, hey, do this, and when it comes back, I want to do this with it. Everything in JavaScript is like callback, and sometimes there's wrappers for that, like promises or wait, all kinds of weird keyboards for that. Here we're just using more or less plain callbacks because I didn't want to load any more JavaScript libraries because that would have really been more complicated than I want. And then I said, okay, so you get a response and then parse it into JSON. This is great because the response is in JSON, and JavaScript is really, really, the one thing JavaScript is good at, it's parsing JSON. Literally, like that's how JSON was designed. Make something that JavaScript is going to be good at parsing. JavaScript object. And then I tell it, okay, take the response and set the state from that. Okay, so this means that you remember that I set the state originally to map posts to an empty list. Oh, that's probably not the list that people want to see. They want to see the list of actual posts. So this means once the component is mounted, go grab the post and reset the states. So React works in this way where it's kind of a convergence loop, meaning you set the state and then you tell it how to display the state, we'll get to eventually, and then it will make sure that the page will converge to what you want the page to look like. This is called the virtual DOM model, and it's part of why React is not the fastest, but it's also part of why React is not hard to make reasonably fast. Because you do not have to worry about what changed. You just say, here's what I want things to look like, and it will magically just make the right thing appear. Again, this is very different than if you're writing JavaScript yourself, so you should be very happy. So how do we do that? In real life, this would be the job of like maybe a front-end designer to like, carefully come up with the CSS abstraction and stuff like that. I'm really old, and I'm used to like the time where we just wrote HTML by hand, so I'm just writing a URL list item. This is a very straightforward, right? So again, some things to kind of note here is that in React, the way I kind of interpolate into the HTML is explicitly with braces. We'll get to the get form later, but I didn't want to embed it in this page. By the way, like I should really have put it in this page. The main reason I didn't is slide kind of density. In real life, you'd have the whole form right here. I wanted to make sure that I get to talk about each part in its own slide, and not to have a slide that has like 50 million lines of code with like really small font, so hopefully you appreciate it. In real life, this would just like literally be embedded. But this is the part I want to talk about right now. So this is very similar to the Python map. Right? If you used to use map in Python, you give it a function and an iterable, and it will run the function on each of the iterable and return to you a list of things. So here I'm telling it, okay, map to post. Post, as you remember, is the JavaScript list because it parsed the JSON. The JSON was a JSON list. It parsed it into a JavaScript list. And for each item, right, this is a version with the author. So the way I chose to represent author was just have a pair. So an array of two. The first one is the content, and the second one is the author. And then just display it like that. That's not necessarily the cleanest way, but it is optimized, again, to look good on a slide, which is the most important thing for a tutorial. So this actually shows, and one nice thing is that this brace format, who remembers when I explained what XSS is? Wow, 2 hands. So XSS is 3 or 4 hands. I'll kind of go through that again. XSS is short for cross-site scripting. It's when someone puts as the author field, open bracket, blink, close bracket, haha, /blink, and then you get something blinking. This is like the prank version. The real version is when they put script, SRC equals, and then they just basically hijack your entire page, and everything is bad. So you don't want that, ever. This is protection against that. So what braces do is tell it, take this and make sure that this is what the user sees. If people put, less than script, you will show them less than script. You will not, make them execute the JavaScript that you don't intend to. So this is great because this is automatically access protection. Right? Again, you can convince You can convince React to actually like display raw HTML, but then you'll have to actually work at it. So hopefully, if you get to that point, you've done your due diligence and you know what you're doing. But yeah, that naturally, like you'll just do that. So this is great. Yeah, so this shows the list of posts, right? The page has, more or less one job to do, which is to show the list of posts. It's doing it. It's great. Everything is good. So as I said, like in real life, and literally in the first version of code I wrote, get form was just embedded there, but it was kind of annoying for slide reasons, because this is, as you can see, kind of long. And there's a lot to talk about in here too, so it's nice that it's on a separate slide. But by the way, that refactoring is something that is sometimes useful to do, even not for just slide reasons, but just to make sure that each method is easy enough to write on its own. So you can refactor things in React, and you notice that nobody raised their hand and called me out on like something that should look like a lie. So I'll tell you what I would have heckled, how I would have heckled myself if I was in the audience, and how hopefully I respond. So I told you this is XSS protection. This means that this will never display HTML, right? If there's HTML in it, it will wrap the HTML in end, LT, comma, so it will actually show the. But here I'm using this .get form. And get form should be interesting HTML, right? It should be form and JavaScript stuff. It's exactly the kind of thing you should be really, really worried about when you're worried about XSS protection. Why did this work? So I did kind of tell a lie. This will show it the right way. And what I mean by the right way, if it's supposed to be a string, if it's a string you got from JSON, then it's a string. In React, XML or HTML is a different data type than a string. So when you interpolate it, it does the right thing with the data type, which means if you get it to be, if it is HTML, it will interpolate the HTML. If it is supposed to be a string, it will protect the string, right? And since all the methods return an HTML type, they do not return a string, right? This is literally a different type. It's a DOM type. And this is fine. Okay, so this is like a subtle point that is really, really important to get wrong. So I wanted to kind of put a little bit of stress on it. So the right way to do forms with React is to use React. And what I mean by that is, if you look at kind of tutorials on how to do JavaScript and forms, they will have all these details, but like the right way to do it is to literally use like the React primitives for that, because the React primitives will just do the right thing. You see that here, I'm giving a method type, a callable type, as something to interpolate. React will do the right thing around that, which means it will auto-generate weird JavaScript, which will find that method at runtime and call it for the on-submit and on-change and so forth. So note that this open brace is very, very powerful. It doesn't just handle DOM, which you say, well, handling DOM is easy, just insert a DOM. It doesn't handle string, which you say, well, it's not that hard, just, wrap everything safely. But it also handles callable. It handles a lot of data types that are really, really annoying to deal with, like, in just like abstract JavaScript. So it literally can like direct you directly to methods, whereas usually the on-call is just like a JavaScript blob, and you have to make sure that you call that method yourself, which is really, really hard, easy to get wrong. And this is, by the way, why we had to pre-bind them. If you remember these methods, handle input change and handle input submit, these are the methods I had to rebind to make sure that this is like fully glued onto them. This is because in this, otherwise the this would be the this of the, I think, the form object. And again, it would kind of capture the wrong this, and things would look really, really weird. I cannot stress that because it's a really easy bug to make. All you need to do is add a method, right? You're like, oh, like Moshe had like the same method for handle input change here, but like these really should be different methods, and you'd be right if you think that these really should be different methods. I made the same method again, mostly for slide reasons. And then so you make them different methods, but you forget to change the constructor, and everything looks fine until you realize you have the wrong this, and you have no idea why you set it in the wrong this. And the only symptom you're getting is, why is the author field not getting sent in the on submit? So the symptom is really, really detached from the cause, which is why I stress this, so that when you get the weird symptom, at least you'll have some idea that this is one of the causes you should look for. Like I said, like understanding much of what I'm trying to get here is like understanding when things go wrong and how to fix them, because this is most of the work an engineer does. So luckily, handle input change. Like I said, I really do. I really should have made it different methods for the author and for the post, but here I made the same method, and I just get from the event what is the right target. That's fine, it works. And then I do event prevent default. So again, in like regular JavaScript, you have to return some inscrutable object to say don't call the usual method. For the life of me, I can't remember what it is, like maybe none, or maybe 0 or false, or something like that. But in React, this is how you prevent. So the idea that like anything has like its default handler, right? Like when you do something, the browser has already some behavior. By default, the browser will have some behavior. You usually want to prevent this behavior if you're writing React. So almost always in any event handler, you want to put event prevent default. And if you're not putting event prevent default, you want to think carefully about why you're not doing that, what's going to happen. And if you decide that this is good, you probably should write a comment explaining why it's good, unless it's like super obvious, which I've never seen it be super obvious. Okay, handle submit, I kind of broke into two parts. As you see, like the code is unmatched braces, because as much as I try to optimize my code for slides, sometimes it's almost literally impossible. So this is the code for fetch, right? So you see that I'm using the method post. So I send over to the server the contents of post, and I use JSON.stringify. This is how you do string dumps in JavaScript. So this should be pretty obvious, because this is almost the code you would have written if you're using requests to do that, right? It would be like request.post /posts and headers and so on. So this is pretty straightforward. But like I said, in JavaScript, everything is async, right? So this doesn't return to you the result of the page. This returns to you a promise with the future result of the page. And then you have to do something with the promise. So you notice that what I do with the promise is I say, okay, fetch posts again. Why do I do that? Well, you just posted something. Think about the behavior that, like, Twitter or Facebook or any of those things has when you post something. You type your thing, you type submit, and it immediately displays. Right, and then probably opens another window so you can type another deep thought. So this is a behavior we want to emulate, which means after we send it to the server, we ask for it again. Give me the current list again so I can redisplay it. And again, this set state. So you notice that all I needed to do here is set state again. I do not have to explain again how to render. Once you set the state, it renders again. I could probably have abstracted both places I set state to the same method, but it's really not worth it, right? It's like pretty simple code. And again, this time this really matters, event prevent default, because if you don't do that, the default behavior of browser, when you submit a form, it's to submit a form. This means it's going to be in the format application XWWW URL encoded, and like your server is not up for that, and you'll get like a weird error. It doesn't really matter unless someone opens the JavaScript console and wonders why you get like a lot of errors. But you should probably don't do that, because it's really annoying when you open your JavaScript console to debug a problem and you get all the errors from the things that nobody thought really mattered. So yes, you should definitely prevent defaults. Okay, I think we're way behind, so these like numbers are by now meaningless, but I'm gonna try and catch us up somehow. But yes, so as you remember from previous attempts, getting it to run as is actually less trivial than you'd think. Luckily, this is almost the same, getting it to run as is, as we did earlier, because we already had the static file. So what you are doing now is just making sure that when you run it earlier, you run it properly. Meaning when you go to localhost 8080, you do actually see a single page application. When you put in a post and an author, you actually get the refetch and so on. So when you initially get it, you do not see the list of hard-coded posts with just chilling and being awesome. Open the JavaScript console and figure out what's gone wrong. You'll get like a nice red, not very nice, but a visible red thing that will tell you where you have made a mistake and hopefully fix it. And then if you do manage to get it to run, it says add a special button that only refreshes posts. So we already saw how to automatically refresh a post when you send it. Now I want a button that only does that only refreshes posts without sending a new post. And if you have finished with that, try to add a loop to refresh posts every 5 seconds. At this point, you're starting to really become similar to, like, again, how things like Facebook or Twitter will work, right? Where, like, they automatically refresh. So when you see the thing, like, in Twitter, you see, like, the 5 new posts. You can click on and see the new posts or stuff like that. If you're finished with that, you can have, like, a special button that makes auto refresh on and off. Some websites actually have that, and that's sometimes useful. And if you're finished with that, try to set the interval time. There is no way I would get to, like, even that in 20 minutes. So again, if you get to all of it, you should probably be teaching the class instead of me. But go ahead and start. Please get it to run. And maybe I'll just, we'll keep it for 20 minutes and see, like, maybe 10 minutes through, we'll see how people are doing and kind of adjust from there. Okay. So just if I think we're around 50 minutes behind schedule-ish. I really don't want to rush any of it because I feel like I'm going to do a disservice to the material. There are, like, subtleties to the material. So as things are looking, we'll probably be dropping the end-to-end testing stuff, which I'm kind of sad about because I was really hoping to teach a class about how to do end-to-end testing so user won't have to find bugs. But it's all in the handout. So if we do drop the end-to-end testing, please read the handout stuff and try to get it to work on your own so you know how to do end-to-end testing. Okay, so hopefully you all get somewhere decent, but we need to move on so that we get to cover more stuff. So yes, originally this was, I think right now we're 35 minutes behind, so we're kind of okay-ish. Okay, so as I said, we're going to choose to run our stuff inside Docker containers. Docker containers are great because it's easy to ship applications in a way that kind of wraps up all the dependencies and all the build parts. And they can run well on a lot of different environments. Somehow containers got to be the poster children for what they call immutable environments. And basically, everyone who runs containers runs them in a way that assumes they're going to be immutable. So you need to know what it is and how you should deal with it. So immutable environments means that unlike the way you usually think of a computer, where you kind of, if you have like, a Linux or Windows or Mac, MacBook, you open a computer, and the first day it's not configured great, right? Because it's not configured the way you want it. So maybe you change some settings, and you install some applications you like, and that's great, right? And then the next day you install some application that you like, and then the next day you remember, oh, right, there's also this application. I only use it once a week, but I need it, and then so eventually kind of the computer gets to be more and more the kind of computer you like. Immutable state is the exact opposite. Immutable state means I'm going to give you the computer. It's going to be configured as is, and if you ever want it configured differently, you throw the whole computer away. Like, throw your Mac in the trash, configure a new Mac. Well, that works, obviously like less well for like, really expensive things like Mac laptops, and more, but really great with zero-cost things like virtual machines or in this case containers. Right? The whole idea of a container, you never modify the software in a container. You build the container the right way. If it's not built the right way, because on line 15 of your Python code, you had a bug that when someone types post and the post has A in it, it doesn't work correctly. You do not change your Python code inside the container. You throw the container away, you build a new one. This means that you're going to throw away a lot of containers, right? If you're anyway like me, you sometimes have bugs in your code, you're going to be throwing away a lot of containers, right? So this means that if you want to have state, right, say a list of posts that people have done, you cannot put it inside the container. Because you're going to throw it away in like 5 minutes when you discover you have a bug. And then you're going to throw it away, and you're going to throw it away. And like, when you change your JavaScript was also inside the container. Remember, your JavaScript was served by the same application. You're going to throw all of this away every time. So this means if you need state, you can't put it inside. Well, you clearly need state. So like, in the world of Docker, sometimes people, we want to deal with stateless applications. There is no such thing as stateless application. You need state in your application. It has to come from somewhere, right? Like otherwise, what is the goal of interacting with your application if you're not going to, make the world a better place, right? If you don't share your opinions on Facebook or whatever. So it can't be inside, it has to be somewhere. So there's two popular places for it. One is actually more popular than the other, but we're going to use the less popular one because it is easier to configure. And this is what we optimize for in this tutorial so that we'll get things going in only 35 minutes of overtime. So the less popular but easier to configure is volume. A volume means you mount a directory into your container. So your container is basically a virtual machine. Not really, but let's imagine it's a virtual machine for now. We can talk later about what it really is. You can mount a volume from your computer or from whatever server it's running on into that. Say, you put that volume on /state, and then you put all your state in /state. When you throw the container away, that volume, because it was on the a lower level computer, it's still there. So when you put another container on top of it, lo and behold, it gets the same state. So like our state is now persistent, which is what people usually mean by state, persistent state. So that's really great. Now you have to, of course, manage some directory on a computer. This is not that bad if you have a laptop and you run your applications on and off on it, but probably that's not going to actually happen like in production. So if you say you're running on AWS, you'll usually be mounting a special EBS volume, and like modern container orchestration frameworks allow that. And I really don't want to get into all these details, but if you look at like pets, it used to be called PetSet until Kubernetes figured out that PetSet is a stupid name and they changed the name, but I never remember what's the name. They changed the name of, I think they call stateful something, but it used to be called PetSet. So if you Google for Kubernetes PetSet, you'll find the modern name for that, will allow you to like manage volumes on your containers. ECS has a similar thing that I also forgot the name of. Anyways, there's decent ways to mount volumes on the containers even in production. And you can manage that, and that works well. And you can, like shuffle some files around, and that works well. Usually, like, this solution scales your web stack at the same speed as it scales your storage stack. Luck is having two things that happen to coincide. And this is literally like when you're counting on this, you're counting on luck. Like, I'm not telling you what's going to go faster, but saying that these two things are going to grow exactly as fast is like, literally hoping for a miracle. This usually will end up scaling to a few machines, and then you're really going to scale out of that solution. And the other place to put it is on the network. So the network is basically, like all networks, it's a lie, right? I don't want to manage state. Let's have this other thing over here manage state, and I'm just gonna have it manage state for me. Luckily, lies work well, in a lot of cases. Say if you if you're using Heroku, you can get Heroku to manage your databases for you. They're not going to be in containers, or maybe they are going to be in containers, but what they're certainly not going to be is your problem. Now the Heroku's problem. And similarly, if you're running on Amazon, you can have Amazon manage your containers because they have RDS. And Google Cloud Platform has something that's also probably a 3-letter word that I don't remember. So, you can often get someone else to manage your database for you if you throw enough money that way. If you don't want to throw the money outside your company, you can hire a DBA and throw the money at them, and they'll manage your database for you. So that's often like a pretty good solution, right? Like throwing money around. This is like the essence of doing the storage on the network, right? It can either be like a more traditional SQL database, like Postgres or MySQL, or Oracle if you really hate your money, or you can use one of the modern NoSQL, say RethinkDB or MongoDB if you hate your data. Many solutions for many preferences. But yeah, basically, the most important thing is not inside the container. Anywhere but inside the container. Because if you edit a file, it's on the container. In 5 minutes, when you find a bug in your JavaScript, which I'm sure all of you have found a bug in your JavaScript by now, if you're up to date on the exercises, you're going to throw it away. So as I said, we're going to do it with files. Because they're much, much easier to manage, and I don't have to start telling you how to run Postgres on your laptop. If you imagine any of the instructions I gave you so far to set up this class, and anyway you had difficulties, Postgres is more than that altogether, plus the chance to get things wrong altogether. So I thought this would not be a lot of fun. But like I said, because we're using SQL Alchemy, this is not going to matter, right? If we later want to change which database we want to use, SQL Alchemy luckily abstracts 90% of the database details from us. So these are the imports we'll need. And we'll be kind of writing our database abstraction library, such as it is, as a separate module, and then we'll use it from the other modules. This is, by the way, a very common pattern and a very good pattern. So you should probably be doing that. Usually your database abstraction library won't be 5 lines of Python. SQL Alchemy works with an object called metadata, and the metadata is where the schema is constrained, right? Because SQL Alchemy is for SQL databases. SQL databases have schema. They know how your database should look like in advance. And this is also kind of like a stand-in for much more complicated code in real life, but this is a stand-in for complicated code in real life. This is a migration code. In our situation, we won't have migration code. We'll just we'll do the zeroth migration, or the trivial migration from no database to correct database. Usually in real life, you'll have the no database to database you thought was correct yesterday to database you think is correct today, and probably the database you think is correct tomorrow because schemas change. So this is kind of a stand-in for this migration code. And it's again, database migration is like a whole 3-hour tutorial in itself. There's no chance I'm going to get to explain any of it, except to tell you, in real life, there's going to be a migration here. And unfortunately, some of this code scrolls off, but I can tell you what it is, so that's fine. So we have a function called getEngine, and that function called getEngine goes into the operating system environment and gets a variable that you'll have to trust me is actually called blog_db. The underscore db is somewhere here. And it says, okay, that should be the URL for my database. It's not a URL you could type into your browser because your browser doesn't know how to connect to databases, and this doesn't need to connect to HTTP sites. In our cases, the URL will look a lot like SQLite : some stuff. I'll show it later. But the important thing is that this is the entire abstraction for knowing which database to connect to. And again, this is really useful because whatever environment variable you set for your server, it will know how to connect to different databases. So on your laptop, you might be connecting to SQLite. In production, you might be connecting to Postgres. By the way, never ever do that, because that is a good way to kind of have things that work on your laptop and don't work on the environment. But even if you connect to Postgres both on your laptop and on your server, it's probably going to be a different Postgres. Hopefully, you're not going to modify production database from your laptop code. So you still want that URL so that you can point it to different Postgreses. So this is a schema. This is a schema for no authors, because all my examples are no authors, because I think the author was an exercise. So it has a table called posts. It has one column in it. It's called content. You have to believe me that somewhere here I tell it that it's text. But that's it. That's a pretty simple schema. Almost literally the simplest schema you can have. Definitely simpler than it should be. In a real database, I would have another column for ID, so I can address specific posts. Say if someone wants to delete a post or update a post. But this is like really, really simple. No update, no delete shared, because I wanted something simple. So this is way too simple than any real table you'll ever have, because any table that's realistic will have an ID thing in it. And then, again, this is, as a standing for real code, this is really, really typical. You know, you want to abstract the database from your logic. So this means, like, in the DB library, I'm going to write code that has logical functions, like get posts. And this, and this should know how to execute the right SQL select statements, right? I'm not going to actually embed my SQL select statements in the web logic, so that if I change the structure of my database, all the stuff that has to do with the database is not you know, here, like the web application is one file, and this is one file, and this is very simple. If you have a complicated web application where also in the user management, you count posts for users, so you have another place where you get the post, and you don't, if you ever change the structure of the post structure, you're going to have to change it in 50 places. Don't do that. Centralize all your logic in like one abstraction library so that you can call into that library and get data from that, so that if you ever change the structure, you have one place. So this is kind of a stand-in. Also notice that I connect to the engine every time. That is absolutely fine. If you need, if this is too slow and you need to wrap it in something, you still use that logic. And what you do is you get an engine that has a connection pool inside it. I'm not going to cover that, but what's important is that this thing doesn't care about what engine you pass it. Right? So this is like a structure abstraction library. It's not an engine abstraction. The engine abstraction comes from the function create engine. If I had wanted to make a connection pooling engine, I would have wrapped that function in the connection pooler. Again, this is really important because at some point you'll have to fine-tune how your connection policy is, and you want to make sure that when you fine-tune that, you don't have to change the structure of your database. Those are separate concerns, even though both concerns have the word database in them. So then I have add post. It's similar, like it uses insert with SQL Alchemy. So again, this is all like very standard SQL Alchemy code. It uses SQL Alchemy to make sure that you don't have to care about, you know, different databases. Some of them might be case sensitive, some of them not. SQL Alchemy knows all of that. You don't have to worry about that. So now we need to change the application to connect to the database and not, you know, like the in-memory list of posts of like just chilling and all that. So in the configuration setting, we need to add these two lines. We ask, hey, get me the engine. If you remember, that function goes to the environment variable blogdb and gets the appropriate engine. But this code doesn't care about it. It doesn't care about how you configure the database. It just knows this library knows how, the storage library knows how to get me an engine. And then, you notice that I add it to the configuration settings. So this is like every single framework will do it a little bit differently. Django has obviously the context object, which is where you'll find your database. Pyramid doesn't have like any kind of tight binding like that, but it allows you to put like specific attributes on the configuration and then be able to retrieve them later. So this is a good way, right, to separate your configuration from your logic, right? So what we need to do is now use that engine that we set as an attribute on the configuration in our methods. So, and this is how we do that. So we go to the request. Remember that you get one of the arguments you get is a request. The request has a registry attribute. The registry attribute has a settings attribute, and that setting attribute is exactly correspond to the settings you have on your configuration in Pyramid. So when you get the engine like that, you get the engine that was set in the configuration. This is really nice because, like I said, in like a typical web application, you have many, many files doing web stuff. If they all do that, then when you change how you change the engine, you only have to modify the configuration part, the routing part, and you don't have to go into like 50 different files and change how you get the engine. And even nicer, because I use storage get post engine, this function, you notice, it doesn't really care about the, what's in engine. All it knows is engine is a good enough object to pass to storage get posts. Since engine is something I've gotten in storage, if I change the engine from, say, using SQL database to using, say, a NoSQL database like Cassandra or MongoDB, I only have to change the storage library. It'll be a big change in the storage library, but at least it will only be in the storage library. And this is how we do the add post. This is the modification to the add post function. And this is migration code. Right, like I said, like real migration code is often more complicated. Part of it is because it needs to do more things than just going from no DB to the correct DB. Usually in real life, you get to the database that I thought was correct yesterday to the database I think is correct now. But here, we have never made a mistake because this app only has to survive for 3 hours. We just have to create it. So we use the method createAll. Remember I said createAll basically stands it for the migration code. This is how we run createAll, right? So we just export the blog database environment variable. We tell it createAll get engine. Get engine, and remember, it goes and checks the environment variable and makes a SQL alchemy that's connected to this environment variable. This environment variable, you'll have to trust me that this is how you actually type a URL for SQLite. So this SQLite, it tells, the file that's right here that's called blog.db. And so this will initialize that file, and we'll make sure that this file has the correct schema, which again, in our case, is like one table called posts with one column called content. But again, in more realistic scenarios, it will be a lot of tables with a lot of columns. I think we're doing pretty well on time. Whew. So if some of you remember that you had a problem earlier when you tried to run the thing with a database and you couldn't get it to work, now you should be able to get the version with the database. So if you change the blog plugin from app.nodb from app to app.nodb, change it back to app, see that it fails because it can't find the right environment variable, and now set the environment variable before you start the web server. Again, it will fail because that file will not exist. So you have to write the migration code that I showed you earlier, and because I showed it to you earlier, it's also in your handout. So run the migration code. You run your web server, see that it works. If this works, great. Again, using the logic you already have for adding the author to now also save the author in the database. Right? That'll be nice. That we don't just display the author, we also remember it. And if you're done with that, you can try and renormalize the author to a different table. Because I didn't teach you how to write proper migration code, you need to create the database from scratch. Storing and creating database array is definitely something you should never do in production, but it's fun to do in development. And if you're finished, you can also add an auto-calculated date. And since you have 15 minutes, I doubt anyone will get to the end, but it's going to be a fun ride. So let's try this and see how far we get. And we'll kind of talk again in 15 minutes. So just FYI, if you try to copy and paste from the PDF, it will give you the wrong quotes, the wrong star, and no underscore, so make sure to pay attention to that. I know like a few people have already run into it. If you have not run into it, I guess I've saved you the time that you spent to troubleshoot that. Okay, So let's try again a quick show of hands. Who got it to work to just run it with a regular database? Okay, I see most people. Who got it to run with author? Okay, a few people. Okay, I think we're good. So I think we're gonna move on because we do have a lot of stuff to catch up on. Okay, so this is a good example for how not to ever write your Docker file. Like I really want to emphasize that point because I don't want you to write those Docker files like Moshe taught us. But this is a good example to explain how a Docker file is structured and how these things. And later on we'll see an example of how to write a proper Docker file. But this shows like the main ideas in a Docker file. So what is a Docker file? So like I said, Docker containers are made to be immutable. Means you build them right, and if you build them wrong, you throw away and you build a new thing right. So this is the recipe. This is how a Docker container image is built. After you build it, you'll usually ship it off to a Docker container registry, and there it will sit until like you pull it and run it, and that's like a whole different story that is not important like for right now. But the important thing is that if you use Docker build with this file, it will produce a container image, right? So while it's a really bad way to run a Docker, it is technically correct. So let's kind of go over the anatomy of a Docker file. It always starts with a from. So a Docker file will always start with like, which image am I basing it on? And you might think like, there's some images that are meant as bases, some images that are meant to run. No, there's like one type of container images, they're called container images. Every single image starts a build with that. And again, like, you guys are not heckling enough. Like the obvious heckle is like, well, how did they build the first image? Good question. There is like an initial image called Scratch that is literally the empty image. It is an image with 0 files, and it is created manually, not via Docker build, and is uploaded to the official Docker registry. So like people who really wanted to build from scratch, say from scratch. I think someone thought it was like a really, really funny joke, and now we all have to live with this funny joke. Yay. Anyway, usually you do not want to build from scratch, but you want to build a pre-built container image. One of the set of images I like the best is the Python colon. We'll kind of get to like, why there's a colon afterwards later, but like that whole family of images is good. One thing that makes them good is that even though they're all built on Debian, they do the one thing that you should always do on a Debian system when you're using Python to develop application, which is never ever to use a system Python. This does not use a system Python. It builds a custom Python. If you use colon latest, it will build the latest Python version, which nowadays is 3.6.4, I think, or maybe 3.6.5. Anyway, this will get you Python 3.6.5, which is not a system Python. It is a custom-built Python for you to run applications. The Debian Python is right there for running Debian stuff, and that Python is to run your stuff. I think some of you already had problems in production with custom Debian, with the standard Debian Python. I think those of you who are running on Debian or Ubuntu have seen that the VM works in really weird ways. That's because Debian really hates you to use VM, but it doesn't want you to use pip because it wants you to use its own package registry, which is great for Debian. So this does not use a system Python. If there's one thing that I've taught you that I want you to walk away from this tutorial is to never ever use a system Python to develop your application. You'll be sad. It doesn't matter which system. It doesn't matter if it's Debian. It doesn't matter if it's Fedora or Ubuntu or Mac. Never use that. There's a lot of other alternatives. Anaconda is one alternative. Using this, if you're using Docker, is one alternative. Using PyEnv, if you're on Mac, is a good alternative. System Python, bad, never. Then we set the environment variable. So one thing that Docker containers let us do is set a custom environment for the things that run inside it. Hopefully you're all familiar with this asterisk environment, having spent a few minutes trying to make sure that your code runs correctly with it. Then we pip install. You should also be familiar with what we pip install here, because this is what you pip install in your virtual environment to make sure that you can run the application. And then we have to copy our stuff from our source into our container image. That is done with the Docker command copy. So we copy the twisted little block directory, which together compiles basically your Python logic. and we copy the index.html on the static, which you painstakingly make sure that like is serve the static files to the same place. And then you set srcs work here, right? So that's so this means this will be the current working directory. And when you try to actually set it up, it will work correctly. You notice that the blog database is not set to the source directory, it's set to mountDB so that we can mount this volume from outside. And then we use the SSL entry point. It fell off the page, unfortunately, but you're very familiar with this entry point because this is literally the command you've been running for the last hour. So it's Python-m twisted blog. So you should be really, really familiar with it. If not, then I've definitely been doing something wrong. Okay, so this works. Like you Docker build this, you Docker run it, it will actually work. Also, why did I tell you to like never ever do that? So here are the issues here. So one, Python latest. What's latest? As you remember, literally 5 minutes ago, I made a mistake. I told you that latest is 364 and latest is actually 365. This is because I'm not that up to date, and I remember 2 weeks ago it was 364, and I haven't updated by internal cache. I think I'm pretty good at this stuff, and yet I've made a mistake in this tutorial. After having practice, you're going to make the same mistake. You're not going to be sure which Python version you're running. Right when 3.7 is out, this is going to migrate to 3.7. Guess when is the worst time to figure out that your code has slight incompatibility with 3.7? The answer, if you answered when I'm rebuilding my Docker container because I fixed a JavaScript bug, you're right. So latest is bad. It's like literally a bad word. Right? It doesn't describe anything. Current latest is not the same as 5 minutes from now latest. Right? The world changes. Latest is bad. So what do we do instead? There's better tags. I told you I will cover what comes after the colon. You can tell it exactly which Debian to start from, right? So Debian also updates stuff, right? When we started at work, when we used latest, it was using Jesse, and now it's using Stretch. However, because we were careful about it, we explicitly asked for Jesse, and then we changed our container explicitly and asked for Stretch. So when we had bugs coming from that, those bugs were on a pull request that we could fix. This is a great place to have bugs on a pull request that you can fix and not in production. So latest is a bad word. Never use latest. Try to figure out which thing you should have. And sometimes it's even there's other techniques I don't cover here, but if you look on PyVideo at my PyTexas talk, I covered how to fork tag to make sure that you really know which version you're running from. I'm already 35 minutes late, so I'm not going to cover that here, but yes.
Same reasons apply, or the same thing applies to the pip install.
Yes, exactly, yes. So thank you for being a good plant. This is a bad pip install. It is a bad pip install because of the same reason, right? When Twisted updates their code, even with a careful deprecation policy, you do not want to run into a weird Twisted bug that is caused by the fact that Twisted just released, and now you're testing it for them. No, you want to make sure that these updates happen. So this is a bad pip install. Finally, this is a bad pip install for another reason. There's nothing to correlate this pip install with the code you have in blog. Right? And what do I mean correlate here? I mean, maybe someone who was working on the blog code needed a different library. How are they going to communicate that, right? Are they going to change that pip install line? That's bad, right? So that pip install, and then, so basically the reason that we manually copy the files into SRC instead of producing a real Python package, in which case if we didn't pip install the right thing, installation will fail. That is good, because you know that you forgot something in your pip install and you're going to fix it instead of having a traceback, when someone does the function that nobody ever does because it's only in the admin interface. Now your admin interface is broken in the production app, so bad. So how do we fix those issues? Well, we write, I forgot one other thing that is bad. There are many bad things. So also, even regarding, not about the latest, but what is in that latest image? As you can see, this works. This should actually scare you that it works. Why should it scare you that it works? Because pip install twisted didn't fail. So why should pip install twisted not failing scare you? Twisted has a C extension. If pip install twisted is not failing, this means this image has a C compiler in it. You're shipping a C compiler into production. Now, let me assure you that this makes the person who finds the remote hole in your code much, much easier to operationalize it. Like, you clearly don't want to ship RCs in your code in general, but in general, not shipping GCC makes it much harder to operationalize your RC, and possibly even getting there. You know, like, ideally write secure code, but don't make it easy for, you know, like the adversary. So this is bad for a lot of reasons. Wow, remembering all the reasons why, but the worst thing about this is that it works, right? Like if you just Google for Dockerfile for applications, you'll get this, it works, you ship it into production, and that's it. As I said, this command that hopefully you all done in your prep statements, and I realize it failed for many of you, but you know, like obviously, like if you get Docker properly configured, it works. And this is like the worst thing, right? That this command actually works. The naive Docker does serve a useful utility in this specific tutorial, in that because of the order it's built, it means that even if you don't have network, if you warmed up your Docker cache correctly, you can change your code and it will work fine. This is not a good reason to use naive Docker in any other situation other than being stuck in a tutorial room with poor internet. Hopefully that's like, you know, not too much of your life you spend that way. So you run it. You'll notice that I run it with explicit volume mount. This is a very typical way of like running a Docker container locally, right? You explicitly post the port from 8080 to 8080. This means whatever you serve internally on 8080, please serve externally on 8080. Again, there's better ways to run Docker. I do not want to get into them because this will take even longer. The volume mount is the most important thing here because this means that the database will now be sitting on a file on your actual hard drive, not inside like container and thrown away when you add the container. And again, if you were using this image on, say Kubernetes cloud, you could, you know, with enough pain, configure Kubernetes cloud to make sure that this volume will also be mounted and this will be on a persistent drive and backed up and with all the magical stuff that Google Container Platform or ECS gives you. I think ECS is not that great at that. Google Container Cloud is actually better. But now Amazon has EKS, which as soon as it is out of beta, will do the same thing. Right, so as I said, we don't have a setup file, which is why we had to copy the files manually. That was bad for so many reasons. Look at this. Now it says install requires these three things. So now we find the packages. This is, by the way, a very common thing you need to do if you ever write a Twisted plugin, like we did, to make sure that our static file is served. You need to edit explicitly. It will not find it itself because of very annoying to explain reasons. And then we have our dependencies. So this is a set of files. You notice it doesn't have anything that is not absolutely mandatory. That is not great. You probably want at least the name of the version there. Like if you actually, like when we run this, you'll see that like, you know, it gives you like unknown equals 000. The reason for unknown equals 000 is unknown is the name, because it is unknown, and 000 is the version, because they do not have a version. However, properly putting versions of things is like, again, something I could give like at least a 1-hour tutorial about between versioneer and bump version and incremental. So I do not want to get into that. Put a version on it some way. And, you know, clearly put a name on it. I could literally have put like a name like, you know, tutorial blog or something like that, but I really want to show what is the minimum you absolutely have to do. So if anyone tells you that it's too long to write a setup file, like, this is like the minimum you have to do. This does not take too long, man. So I'm doing from Python 3. This is also not great, by the way. From Python 3 means you don't know the exact version of Python, but I wanted this to be an easy thing to explain. You don't even know the version of Debian, so it will switch the versions of Debian randomly. But it's a good first approximation. Now, even though we're not using the system Python, we're using a custom Python, it's always good to have a VM. And the reason I like to have a virtual environment inside my Docker, which is weird because virtual environment is an isolation mechanism, Docker is an isolation mechanism, why do I need to isolate? You often find that like you need like another side service in the Docker container that has slightly different dependencies, and then you have like an environment with way too many dependencies. That's bad. Put it in a virtual environment. Virtual environments are so cheap. That's like the word virtual in virtual environment. It kind of mostly depends on the real environment and only copies like the things it actually absolutely has to. So they're very, very cheap. No reason not to create a virtual environment, just to, keep your mind at ease. And I put it in /append. This is important. Remember that I put it in /append. This is like a Chekhov's gun. It's going to be important in like 4 slides from now. Then you notice that I still copy all these things because I want to build the wheel inside it. I do not want to pre-build the wheel. There's like different ways to build it, but the way I'm showing you is like the way I like the best because it's the most repeatable build setup. And then you notice that the only thing I need to do is install /src. By the way, this still has the issue we pointed out earlier. It will choose the latest versions of like Twisted and Pyramid and SQL Alchemy. In real life, what you should really do is like you should install from requirements and then install this --1 dependencies, but fail if any dependencies are missing. This is the most secure way. But again, actually getting a good Docker file, like from like a bad Docker file, takes a lot of work. I'm showing you here like hopefully the most important bits. Wow, I think we won't have time for like the hands-on, but hopefully we'll have time to actually cover the entire multi-stage Docker build. We'll see why it's multi-stage in a minute. So now you notice that like in append, which is a directory I already built to be my virtual environment, I also put a directory called website, and I put all the static files I need there. Why am I putting this all in the same directory? Another clue for the whole Chekhov's gun. Now the gun is being taken off the mantelpiece. So you notice that I have another from in the middle of the Docker. So this is what they call a multi-stage Docker. I think it's like supposed to remind you of multi-stage rockets, but exactly unlike multi-stage rockets, there's no reason for ever more than 2 stages. I'm not a rocket engineer, but some of my friends who are assure me that there's good reasons we have like 3 or 4 stage rockets. I believe them. Never, or like I said, maybe I should say it this way. If you ever find yourself with needing more than 2 stages in your Docker file, your life is really, really bad. You have made some bad choices in your life. And the reason I say that is because everything up to now is going to get thrown away by the time we are done with the build, which means in the build stage, you can put whatever you want in it. So even if your code is made up of a combination of like C code and Fortran code and COBOL code and whatever else, so all the compilers in it and like build all the build stuff. Like luckily we only had to like make sure that GCC is installed, which we did by installing Python 3, and we kind of like use pip to compile the C extension in Twisted. But even if you need to compile custom Fortran extensions, that's okay. You can do it in the same container. Like the only time I can think of like needing more than 1 stage is if you need 2 Fortran compilers that are so different and so incompatible you cannot install them both at the same time. I know how you got to that point, but at that point you really should like look inside your heart and figure out like how has your life taken a bad turn. So really like. But I'm serious. Like, if you ever think you need more than 2 stages, stop and think, like, why can't I do everything in the first stage? Like, there's no reason. So, like, the whole multi-stage could have just been called 2-stage, and it would be, like, 99% as good. Anyways, but 2 stages is definitely better than 1, because here we install Slim Stretch. So Stretch is a version of Debian, because that's the name of the Slinky from Toy Story. I'm not kidding. I wish I was kidding. No. Stretch is the name of the Debian release because of the Slinky from Toy Story. The Slim is the important part, though. Slim means do not give me like compilers or all of that stuff. I do not need them. Please do not have them in the build image. This means you're shipping a Slim image with hopefully less opportunities to take control of your images and also, less stages, less stuff in your image, so you don't have to ship, useless bits around. All around good. But as I said, this causes everything that happens until now, all the hard work we put in, all this, useless. All this is going to be thrown away by the end of the build. But by the end of the build, not in the middle of the build. So we can copy from stage 0. The official recommendation from Docker is to name your stages, and then instead of using the numeric index of the stage, the name of the stage. It is a stupid recommendation. There's only 2 stages. 0 is a perfectly fine number. If you find yourself needing to copy from 1, you're needing more than 2 stages, it's bad. Don't do that. So from 0, no need to name stages ever. But if you do, it would have been, the original line would have read from Python 3s build stage. So I would do copy minus minus from build stage. So I copy append to append, but I copy from stage 0 to the current stage. So while I throw away everything I've done so far in the original container, I do move everything I did in append. Remember how I put everything that I cared about in append, including my virtual environment and my files? This is why I only need 1 copy command. Why do I care about the number of copy commands? Because every single line in a Docker file is another layer. The less layers you have in a Docker file, the better off you are. Sometimes that leads people to write 1 command that are like really, really long. If you've ever seen a Docker file that says run, blah, 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 backslash, and backslash, like these, magic things, that means one thing. They were not using a multi-stage build, which is the only correct way to build Docker files. Right? If you need that, I didn't care. Notice I didn't care how many layers there were in the build stage. But I copy 1 directory, and all these layers are magically gone. I don't care how many layers I have to throw away. Like, they're going to throw away. This is like the magic, right? So if you ever seen that, that's like, example, the best example for I know to ever do that. Unfortunately, I do have some zero-length layers. Zero-length layers are not that harmful, so that's fine. Basically to set parameters. So blog database is set to that environment variable. Work dir is set there. By the way, this is like a bad environment variable. The right way to do it is, of course, to hard code, or at least to soft code, the directory you're serving, so that you give it as a parameter and not use the current working directory. But that would have made the previous codes more complicated in the twisted layer, and I definitely don't want to add complications there in the tutorial, but this is not a good example. And expose 88. Expose 88 is actually important. You want to make sure that you explicitly say which ports you expose. Although when you run a Docker container, you can force it to expose any container, because the general philosophy behind Docker is the person who runs should have the most control, right? Because they know what they're actually running, and the person who built it is possibly far away and has no idea what's going on. You should still be explicit, and in general, in kind of good container running platform like Kubernetes, this is actually going to be in use. So you should always expose your ports. And that's it. We set the entry point. You notice we set the entry point to be from the, this is how you use an unactivated virtual environment. It's really important. You want to activate virtual environments when you're developing, because doing that all the time when you're developing is like really, really annoying. You never want to use activated virtual environments for production. For production, always use them unactivated by just using explicit path into the virtual environment. This means if I have 3 different virtual environments for 3 different processes, I'll just have 3 different command lines with explicit paths. This is really easy to read and understand which command is running in a virtual environment, whereas if you start playing around and mucking around with environment variable, there is no way you get that clarity. So that's it. That's the multi-stage Docker build. I think we're like 5 minutes away from getting it to run locally, so I think we're gonna skip that to, we covered the Docker stuff. I wish we would have had time to do a hands-on run, but I think that is not in our fate. But hopefully you can get what I taught you so far and kind of try to get it to run on your own and see how that goes for you. And we also had to skip over the end-to-end testing. Again, I highly recommend reading that stuff from the handout, seeing if you can follow that, because that is a really, really useful skill that unfortunately not enough people have. This is why I kind of try to push it out. I wish I would have put it in sooner, but I couldn't. But even if we had covered that, right, and I was not like, insanely optimistic, I think, when I suggested tutorial, it was definitely my intention to do A to Z. As you can see, 3 hours is barely enough for A through E. So what's missing? So I don't want to cover what I'm missing, just so you know, what other skills you want if you kind of be a classic full stack engineer. CSS. My pages looked horrible, right? Like they definitely did not look like anything you expect from a modern application. They functioned well, right? Like we used modern React, and that was great. But you want to use CSS. CSS with React is a little bit different in that in React you do want to use inline styles because the idea of React is each component should be its own thing. So you want to make sure that the component looks good and functions well. And then, make the inline styles work together. But the idea that the component is, that is definitely the official recommendation of React. You can take it or leave it. Now remember that I told you never to run Bubble directly from your HTML because this means that the end user browser is doing translation work, which is bad. I wish we would have time to cover Webpack. Webpack is what you should take your JSX and transform it into a JavaScript that can run on the end browser. So you just chip and minimize. So what we wrote when we wrote JavaScript, I see some people are a little bit confused, so I want to clarify. When I told you all that we're running JavaScript, I was lying. You can tell I was lying because in the HTML, you didn't see script language equals text JavaScript. You saw text Babel. That's because I let Babel translate it from JSX, which is this React-like language which allows you to avoid cross-site scripting attacks, to actual JavaScript that browsers understand. Doing it inside the browser, doing that translation inside the browser, is not a great idea for production app. This means that when the user loads up, the browser is doing extra work. The browser is having to take this not JavaScript and make it into actual JavaScript that it can then evaluate. This is bad. Right? What you want is to do that work on the development side, like ideally like when you build your Docker container. Webpack is a tool to do that and more, and it also will make sure that your JavaScript will be smaller, which is, again, not a big deal when you're writing barely 20 lines of JavaScript. But if we were writing like a real single-page application, most of that work on the front end ends up like being JavaScript. There's a lot of JavaScript. Making that JavaScript 50% smaller means that the browser will be faster, your load time will be faster, everything. Webpack does all of that. I wish I would have had time to give like a good introduction to Webpack. I do not, but at least I want you to know the name so that you can Google that and learn how to use that. Continuous integration. So after you have the end-to-end testing running on your laptop, you probably want to run it in a CI server, like something like Circle CI, or Jenkins, or whatever it is you use. Continuous deployment, meaning once something is merged into master, you probably want to deploy it at least to some staging setup, if not to your full production. Some people are all out, it's merged to master, it's deployed to production. You didn't want it to deploy to production, please do not merge. If you're a little bit more cautious, at least you still want a pseudo continuous deployment that auto deploys to a staging setup so people can see how it all works together. For that, you usually want to integrate with something like ECS or Kubernetes. Again, no time, but you should know that this is part of what we think of as the pipeline of a modern web application. TLS, something that you sometimes maybe inaccurately call SSL. SSL is not a word you should ever use because it is a stupid word. It literally describes a standard that is obsolete. Nobody uses SSL. When you use HTTPS, it means HTTPS secured, which in any modern browser will not support any version of the standard that was actually called SSL. It will only support version of a standard called TLS. How to manage your certificates with stuff like Let's Encrypt or ACM, and how to rotate that is a whole kind of 20, 30-minute tutorial in itself that you should do if you do not want your content hijacked, which is not fun. Monitoring, right? Things go badly in production. Pinging, logging, metrics, stack traces, alerting are all things you should integrate into your application very early on in the development. It's much harder to edit later. This is all stuff you should have been thinking about, when you were writing the first line of code back then. I didn't talk about how to do redundancy and how to do make sure that things are correct when things crash. I told you that we're only doing the extreme or aggressive data migration, where we delete the old database and create a new one, which is great for development, not so great when your users already have posted a lot of what they at least think are clever witticism to your site, and you're just trashing them. So you want to do careful data migration. And I didn't cover how to do backup and restore for backup, which is also super important for a full stack web application. You want to integrate it into your life cycle to make sure that you have regular exercises of recovery from backups, because a backup that hasn't been tested for recovery is probably not working. Trust me. Your database could say that it's backed up, but if you're not actually practicing regular recoveries, the backup is not working. And I think with that, skipping over a section and a half, we have reached the end. Well, I didn't get to cover Selenium to my regrets. I did get to teach you about how to use SQL Alchemy, Pyramid, React, Twisted, and Docker, hopefully in a way that will give you enough of a start when you want to use them for real. And I think we have -1 minute for questions if anyone has, but if anyone does have questions, I'll kind of take them for 2 or 3 minutes. Yes? Do you have a question? You good? Okay. Okay, hey, yeah. Okay, thank you everybody.
Thank you.
I got the database working.